Hey guys, welcome back to the GSP YouTube channel, and today I wanted to do a quick impromptu video on some basic stuff inside of your Terminator X tunes that you're going to be looking at on your laptops. This is not going to include anything like boost, drive-by-wire, transmission, nitrous, any of the extraneous stuff. This is purely just for the ICFs that are going to be included in every single Terminator X setup. Currently I have a LS bass tune from Holly pulled up, and I just picked LS because it was the first thing that I came to. All this stuff holds generally true for your Ford and Chevy and Dodge stuff, small block Chevy that is. Only differences are maybe going to be some idle stuff like pulse width modulated IAC versus your 4-pin stepper motors, but we can get into some of that later. So the point here is for you guys to understand how all of these ICFs work, because I've kind of felt bad for some guys lately that had to wait on me to get home and get my laptop out to make some relatively small changes that I felt like would be fine if they wanted to, try them and test on their own. When we're talking about major fueling changes or we're talking about spark timing changes, I would love to be involved in that because those are potentially harmful to your engine if something goes the wrong way. If you feel comfortable doing that though, then I'll hopefully be able to show you where to do it in this video. So let's just go ahead and get started, top left here and work our way to the right. This is the fuel ICF, and ICF, just FYI, that stands for individual config file or individual configuration file, however technical you want to get. All that really means is we have global configs that are a combination of individual configs, and whenever you're building a tune, it's just a culmination of these individual configurations that ultimately all work together. Base fuel is pretty self-explanatory, right? This table is for an NA application, and on the column on the left here vertically we've got our manifold pressure, and on the bottom we have RPM. And we're using a VE table here, so this is the volumetric efficiency table. If you switch it to base fuel flow, this is more commonly referred to as speed density. Sometimes VE and speed density will be used interchangeably, but the thing you need to understand between the difference in base fuel flow and VE is volumetric efficiency uses the size of the engine in order to calculate the duration of a injector pulse at a given engine speed and pressure. And so if you're using the base flow, and I want to show you where to change this at, this conversion button does not switch between the two settings. It just simply does the conversion for you so that you can see this table. If you are using speed density, you just need to know that this is a fuel flow in pounds per hour and is not related to whatever fuel it is that you're running, and it's not related to whatever the displacement of the engine is. This is purely as simple as it gets. It means that at this RPM and this manifold pressure, I want you to deliver X amount of pounds per hour of fuel, Holly. That's all I want. We're not going to get any more technical than that. So I'll kind of go through some setup whenever we get to the system ICF here, and that'll be a little more explanatory there. Fuel graph, pretty self-explanatory as well. It's just the graphical 3D form of this table here. The learn table, everybody loves the learn table. Learn is probably the most misunderstood parameter when I am talking to guys. They think that learn is like a process that the engine has to go through or the Holly has to go through. It's not it at all. Anybody coming from the OE world is going to notice that this more or less, it acts like the long-term fuel trims from, say, HP tuners or your OE type engine management. Closed loop acts like short-term, right? So the way that this works is it says, okay, well, at 1400 RPM and 63 kPa in the manifold, I have a closed loop value of positive 10. And it says every time it crosses this point, it sees that positive 10. So the first time it sees it, it'll add 1%. And then the second time it sees it, it'll add another percent. And the third time it sees it, it'll add another percent. So on and so forth until it gets to the point where the closed loop ends up being 0 in that place and the learn ends up being 10. So it's a long-term learned value. And so what you really should do whenever you're tuning your cars, whenever I'm tuning for you, I don't even use this learn table. I only use the learn table in situations where we've run for a very long time on a single tune and have well populated this table. And I suggest the same for you as well. If you are using the learn table quickly, you'll notice that in around wherever you have a big change, you'll see 7 or 8, 9, 10% in a kind of a zone, and around that it'll be kind of circled with lower numbers. The lower numbers aren't good numbers; they just haven't been well populated yet. So you should only use the learn table whenever you have been driving on a tune for, say, honestly, a couple of weeks or maybe 1 week, and you have generated a really nice table here, and you should always come in and look at your table on the laptop before just using the handheld to transfer. You want to look at it in here and make sure that none of these values are just completely out to lunch. They should all be fairly smooth. Anytime you're down here at the bottom and you see really big positive numbers, that means that you've got an exhaust leak or something going on. You got bad data. Don't transfer that. It's not going to be good for your engine, and it's definitely not going to be correct. And ultimately, your car may not run well. So you should always just gut check this, make sure that these are right. If there's interest in this, I can go through more and using a learn table that's been populated. Target air fuel ratio. This is a good one. So when we use a wizard tune that's kind of similar to this one, obviously it comes up as the simple method. In idle, we got 13.8, cruise 14.7, and wide open throttle is 12.5. Those are all actually great numbers. This table here for nothing more than an NA tune is really not that bad. 13.8 may be just a little bit rich for your idles, but if you have a decent sized camshaft, a lot of times 13.8 will actually work really well. What I will tell you is when I am tuning, I like to be a little richer across the torque peak and then lean out a couple percent to go to peak power. That gets done here. You should also note that if you wanted to kind of play with some fuel mileage stuff, that this would be a good place to try to lean out a little bit within reason. Don't go crazy. But anyway, this is your target air fuel ratio. When you want to use the simple method that just uses the top row here, leave this drop down in simple. If you want to adjust the table, and you'll want to use the table for your boosted stuff, it's right there. Just drop down and you can adjust this table accordingly. I'll also want to add this map row right here is directly related to your base fuel table. So if we were to do something crazy like put 210 here, it's not going to let me. You'd have to have a map sensor that could support 210 kPa in order to put that in there. But let's just say I'm going to go ahead and put in 95. So all these values are less than 95 now. If we go to the target air fuel ratio, you'll see that this is at 95. That's where you change that. Acceleration enrichment, also a little bit self-explanatory, but this is what you're going to get whenever you try to rev the car. Your TPS rate of change is whenever you're using the throttle pedal and you're opening the throttle quickly, then you're going to be working in the higher cells. If you're opening the throttle kind of slowly and just rolling into the throttle, then you're going to have less enrichment. This is because whenever you just zing the engine, say you're in neutral and doing revving up the motor, what happens? The engine can't change fast enough. The ECU can't keep up with what the engine is doing fast enough. So the easiest way to do that, there's a moment in time there where the manifold still reads the lower pressure but is on its way to the higher pressure. And so since that is a reactive type measurement, not a predictive, we need to adjust to a predictive style of measurement where we see the TPS rate of change and know I need to add some fuel here. If you have a stumble off idle, this is where you want to take your first look. As so long as your base fuel table is well tuned. This must be done first using slow throttle transitions. Once you have that stumble and you know your base fuel is tuned, then you can come in here and kind of scale this up and down to get a good rev. This value down here, AE versus TPS rate of change blanking, this just simply means that if whatever this number is, if the TPS rate of change is less than this, then it's not going to apply any kind of correction. And that's for whenever you're going down the interstate and you hit a bump a little bit and your foot kind of moves 1 or 2%. You don't want to constantly be just pumping a bunch of extra fuel into the engine for no reason. That's not a significant enough change to need it. And so this value here is what adjusts that. Map rate of change, it works identical except whenever it sees the manifold pressure changing and not the TPS. This is the added fuel that you get. The blanking also works identical. This is a modifier for coolant temp. So if you had a stumble when the engine's cold and not when it's hot, this is where you'd want to look. This is a correction for TPS percent. This means that if you're already at 60% and then you whack the throttle, no added enrichment's going to happen. If you're at 0% and you go from 0 to hero, then a lot of extra enrichment's going to happen. The time versus coolant, this is, I don't recommend modifying these tables too much. The first two are going to be the ones you want to look for. This is manifold pressure, acceleration, enrichment, decay rate. So it's kind of related to, as the manifold changes pressure, how quickly we're going to stop changing the fuel. And then manifold pressure, acceleration, enrichment versus coolant. So this is related to the rate of change for manifold pressure, and it kind of works the same way as the TPS does. It's just the goal here is to be making changes based on manifold pressure changes. This would be, say, if you open the throttle all the way and your turbo is spooling up, you would see a manifold pressure change that's not related to the TPS pressure, or excuse me, the TPS percentage. And whenever you have that kind of situation, you still need to add fuel because ultimately the engine is still trying to accelerate. Temperature enrichment. This is basically your startup fueling, not startup enrichment, but after you have started the engine when the engine is cool. Say it's 40 degrees outside, whatever your base fuel flow is supposed to be in this table at idle, we're going to multiply that by 130%. So engines need to be run at a richer mixture whenever they are cold. Spark ignites the air-fuel charge and is completely related to the amount of available energy, and that includes how much energy is in the head in terms of heat, how much energy is in the block and head in terms of water. It's a sum total of energy that will ignite the air-fuel charge. So whenever you are cold and you just started the car, you need more fuel to give that spark more opportunity to light. Air-fuel ratio offset, this is just, it changes your target air-fuel ratio value based on coolant temperature. Again, to the target tune of trying to hit these colder cells, we want to lower the air-fuel ratio. And then air temp enrichment is exactly what it sounds like. We're going to get richer and leaner based on whatever the air temperature is. Startup enrichment. This is the table that provides the amount of fuel while the engine is cranking before we have a solid signal to the manifold in order to revert to these base fuel calculations. So if your car doesn't want to start with the throttle pedal, or it does want to start with the throttle pedal, this is where you want to kind of adjust. The goal, you have EFI, the goal is to be able to fire up the engine without actually having to use the throttle pedal. Fuel prime is whenever you flick the key on or whenever you fire up the Holly for the first time, it delivers whatever the temperature is. It delivers 150% of that, or 100 if you set it to that. Whatever you set this to, it delivers this amount of fuel times this percentage, 1 shot worth. So that's just a good shot to get the engine started. Some engines like a lot of fuel prime, some don't like any fuel prime. I've done a little bit of everything. It's completely dependent on the application, and honestly, it takes a little bit of trial and error to get that dialed in. But once you do, you can always get them to fire right up. Clear flood TPS just means that if the throttle position is above this value, we're not going to deliver any fuel. And the reason that that is there is in case the engine does become flooded and you have too much fuel in the manifold, cranking it over would only make the situation worse. So if you hold the throttle open above this flood clear TPS, then you can crank the engine over without delivering any more fuel and ultimately, hopefully, get the engine to start. I'm not going to say always, but that is one good way to go ahead and get it to fire up and get it cleared out. After start hold off is how long we're going to apply after start enrichment. After start enrichment is exactly what it sounds, is how much enrichment we're going to run for this hold off time and the decay rate before we revert back to our base fuel. So after start enrichment just means I'm going to run 130% fuel for X amount of seconds. That is set here. Looks like 10 seconds, or at 140. That's just to get the engine running before we lean it back out and work on our base fuel. Fuel control, I don't recommend using this in a lot of applications. This is kind of a setting for getting good fuel mileage, but you can just simply turn the fuel off whenever you're decelerating. A lot of times it ends up being pretty harsh, especially if you have a manual transmission. It's kind of feels like you're either the engine's running or it's not, and that's because it is. It's either running or it's not. Much smoother a lot of times to leave this disabled. All right, so that's the fuel ICF, and I can already tell this video is going to be a little long, but if it's useful, then it'll be worth it. Okay, let's close that and move on to sensors. So when we're using a map sensor, you have to calibrate it correctly depending on what sensor you have. And in this particular case, obviously the internal 1 bar is selected. If you are starting up your Terminator X for the first time and you don't want to use the internal 1 bar, the wizard is going to choose it if you choose a 1 bar application. So you must come in here, and if you want to use the GM map sensor, you must come and select it. It's going to give you an error that says your sensor's been changed. Do you want to scale the software automatically? Usually I select no, and the reason is because 9 times out of 10 it gives me the wrong values that I want anyway. I would rather know what values are in there. At this time I would go back to my fuel and I would set this appropriately. Now we're all set. That's where the map sensor is at. Coolant temp, it's pretty self-explanatory. If you ever have one of these sensors that is not a factory sensor or a Holley sensor, you can always come in here and select the custom application. And this is just simply if you have a custom sensor, 0 to 5 volts, what is this oil pressure in this case over 0 to 5 volts? Pretty easy to put in, and typically your 0 to 5 volt sensors are always linear. I'm not going to say always, just most of the time they are linear. Same thing for fuel pressure. They all work the same. That's it for sensors. Now the system. So this is probably, in reality, whenever you sit down to generate a tune for the first time, this is the place that I like to start. And first things first, what kind of ECU do you have? This just simply in the Terminator X software means X or X max. If you are using an HP or a Dominator, you'll have to choose in the V5 software if you are using an HP or a Dominator. As far as engine parameters, this is just where you're going to choose what it is you actually have. This is where you input your injector data. If you have custom injectors, it's very simple to put in custom injectors right here at the bottom. Injector off time just means that at a given voltage, whenever the injector is commanded to turn on, how much time in milliseconds does it take for that injector to actually become active? There's a dead time that you energize the injector and the mechanics inside of it do not change instantly. There is actually a piece in there that has to move, and due to inertia, you're not able to move that quickly enough to just not use this table at all, and therefore that's what this table is for, is to add this time to the injector calculation so that your injector can deliver the proper amount of fuel. All of these numbers, everything in here needs to be filled out correctly in order for your system to work the way that it's intended to work. Yes, you can lie to it, you can give it the wrong data. I don't recommend it, because ultimately it's all right here. Just put in the right information and all of the calculations will be correct. If you lie to it, you might end up achieving what you're trying to achieve in one spot and end up completely hurting yourself in another. It's just simply not worth it. I kind of alluded to it before, but this is where you can change between speed density, alpha N, a combination thereof, and volumetric efficiency. If you're in VE, when you come here, you're going to be automatically in VE. If you're in speed density, then whenever you open up the fuel, it's going to be automatically in speed density. So if you want to see what the VE would be given this fuel, you click conversion. If you want to see what the speed density would be given this, oh, excuse me, I was backwards. I've kind of wrecked my table now, switching back and forth. If you wanted to see what the speed density would be given a certain VE table, then this is where you would click conversion. I can probably fix that if I need to, but all right. Well, I'm going to keep going because that's kind of outside the scope of the video. As far as fuel type goes, the Terminator X, you can use E85 or gasoline. This changes the internal stoic value from 14.7 if it's gasoline to 9.8 if it's E85. Ignition, this is where you're going to set up what kind of reluctor wheel you have. There's a lot of options in here with the latest software, including custom. You can do all sorts of custom cranks or cam sensor output stuff. Like you can even run a 58 tooth crankshaft wheel with a single tooth cam sensor. It's one thing that's really nice about the Holley setup. With a factory controller, you can't do that. You're either 58 by 4 or you're 24 by 1, and there's no combination in the middle. So NOx sensors, I know a lot of us aren't even using NOx sensors, but this is where you would set that up if you were. Firing order is really important. If you don't have an LS, you would need to change this firing order. If you are setting up a small block Chevy, and you choose a small block Chevy base tune, you won't have to change this, but I always recommend just double check this, make sure it's correct. Sensor scaling, I'm not going to spend a ton of time here because it's pretty in-depth, but basically, long story short, this is where you're going to set all of your various sensors to warn you on the handheld, and then you can also change things and do things based on any of your sensors if they have any issues. Basic I/O, this is where you're going to set up fans, fuel pumps, air conditioning, torque converters, lockup settings, and if you have a bump box or something, you can take that off and use your Holley now because you can set up the ability to do some, like a bump function, either duty cycle or single pulse. You can do like a creep function if you use this. There's all sorts of different settings that you can go through with this. This is where you would set that up if you have a trans brake on a non-computer controlled transmission. Closed loop and learn, this is where you set your closed loop limits. You can set all sorts of, fail-safe handicaps, whatever you want to call it, where we're only going to do closed loop at 150 degrees, and we're only going to do closed loop above 1200 RPM, and We're only going to do it above 2% TPS, and I don't know why you would ever do this, but if you wanted to run open loop, wide open throttle, you could do something like set this to 80 where it'll shut closed loop off. Quite frankly, I don't know why you would do that, because you just spent the money to buy a Holly so that you didn't have that with your factory controller. So don't do that. We're not going to use that. Learn parameters look almost identical to closed loop. It's just like we talked about before, closed loop is an instantaneous correction. Learn is a long-term correction. A lot of times I like to run a lower learn value than closed loop. Gives closed loop the ability to save me if I ever have a problem, but I don't want to learn really bad habits. And whenever I generate a VE table for the first time, I'm pretty confident I can hit it within 50%. So this typically gets turned down to 25 because I'm pretty sure I can hit it within 25% as well. Individual cylinder, this is one thing that's really cool about Term X that honestly, when I first started looking at this, I was surprised it was here. You can use fuel and timing corrections per cylinder. I use this on nitrous cars a lot whenever I'm reading plugs and I see one that, you know, I want to pull a degree out of that and add a little bit of fuel to this, then you can come in here and, I mean, darn if it's not like a 2D table that you can use, you know, your throttle percentage and map, or you can change this to literally anything you want to offset with. We can do RPM and manifold pressure, and I could do RPM versus TPS and have myself a little alpha N kind of, you know, blended deal. There's like a ton of options here that's just really cool, and you can click copy access to all cylinders. You could literally have one cylinder changing base off of TPS and battery voltage, and another cylinder that's changing base off of RPM. What's the most ridiculous thing I can come up with here? Dwell time. Like, I don't know why you'd ever do this, but you can do all of it, and it's actually just really cool that it's there. So inputs and outputs, this is where you all of your ICFs are going to have something kind of similar to this at the bottom, and it's just simply to set up how everything's going to work. If you want to use a ground AC kick, you would set it right here, you know, to ground on the input type. If your AC kick is going to be 12 volt positive, you can set that to 12 volt positive. You can typically, I would recommend running a ground output type. I think all Term X outputs are ground, but you got, you know, plenty of options here that you can do to signal your stuff and to take signals in. So that's going to wrap it up for system and idle. This is a good one. A lot of folks struggle with the idle, and you know, I think there's just a lot of maybe misinformation and misunderstanding on the way that all these different things work, and so hopefully this is going to be really useful. We're going to go top down. So first things first, pick a reasonable idle. That's probably number one. Pick a good idle for whatever engine you have and what cam you have. If you have some Megadeth throw down size of Montana camshaft, do not leave this at 700 RPM. It's not going to idle well there. You might can get it to do it once, but it's not going to be stable. It's not going to want to return to idle well. It's going to dip low. Just don't do it. Don't do it. If you have a big camshaft, wear the idle proudly and set this thing to a reasonable number. I don't know why that did that. Let's go to 1,000. Okay. And then, same thing applies to whenever you're starting the engine up. If it's cold outside, don't try to idle it at the same speed that you want to idle whenever the engine's hot. That's what fast idles are for on, you know, your carburetors in the 50s. If they had it, you can have it too. Let's just go ahead and you know, make this 1250. Apparently I can't type today. 1250. All right, there we go. Now, obviously this dip right here in the middle doesn't look right, so what are we going to do about that? It's really simple. Just bridge the gap, right click fill row values, and then I like to come in here and grab one more on either side and hit smooth, just because I like nice smooth transitions. So there you have it. It's really simple to set your idle speed, and then Holley's going to use these numbers in order to make decisions with the idle air control valve. So it's really important that this is set appropriately. Next thing is the settings. Idle spark just simply means that when this is enabled using a PID loop, and you can adjust the proportional and derivative terms, it's going to run a spark correction plus or minus 8 degrees from whatever you have commanded in your spark ICF, the base table, in order to achieve a smooth idle best it can. Sometimes I use this, sometimes I don't. You should be able to get your engine to idle without this. You should be able to get your engine to idle without an IAC. I'm not talking about ramping from cold to hot. I just simply mean whenever we're working on tuning the engine and getting the idle stable, a lot of times I'll turn this stuff off so that we can achieve a stable idle using fuel and spark in the throttle blade. And then we can turn this stuff back on so that the Holley is not just sitting there band-aiding your idle. So IAC control, this is where you would choose what kind of IAC you have. If you have a Ford, it's going to be PWM. If you have drive-by-wire, it's basically going to be none because it's going to be using the TPS percentage to idle it. If you have GM LSX chosen, then you can come in here and select stepper or PWM, drive-by-wire, none. You can set all this stuff. Either way, you can set LSX, drive-by-wire. All this stuff is adjustable and independent. So ramp down, the IAC hold position, this is the IAC value that the valve is going to go to above 2% throttle. So 3% and up, whenever you're driving around, it's going to give you extra air. And the reason is because you don't want it to have nothing here. If it was nothing, then the engine's going to either feel like it's either on or off, and it's not going to cruise well. And I'm not talking about having a cruise control effect where it holds the RPM up. I'm simply talking about you want to be able to hold a very light throttle percentage and the engine accelerate very little or none, and then as you get out of the throttle, it's going to decelerate very slowly. It's just simply a smoothing thing where you can go down the interstate and not have any trouble. RPM above idle to start ramp. This is where the IAC is going to start closing once you are underneath that 3%. And so 1,000 is probably a pretty good number for most of you. You can lower this some if you feel like you need to. Wouldn't go crazy. RPM above idle to re-enable control. That's where the idle adaptive features are going to take back over. And these are both set above your idle speed. So in our case here, if we were up to temp, we're 200 degrees. Right now, this ramp is going to start at 2,000 RPM. And we're going to start to give the IAC control back to try to idle the car at 1050. Ramp decay time means that whatever your hold position is and it starts to ramp, it's going to do it over 5 seconds. If you wanted to make your engine return to idle quicker, you could lower this value, and you could also lower this value. This I would not mess with. You can lower it a little bit, but if you get too low, what'll happen is if the hold position achieves an idle that is above the RPM to start ramp idle, it'll never ramp down. It'll always stick above, and it's very annoying. Startup IAC position is pretty self-explanatory. That's related to the parked value, but it just means how long we're going to hold at a flat line and then how long we're going to take to decay down to an idle. And these are referring to the parked position numbers. So this means that when the engine's off and the key is on, the IAC is going to go to 50% whenever the engine's hot. It's going to go to 100% whenever it's 0 degrees outside. And it's going to be near 100% whenever you're starting up your engine for the first time of the day and it's 60, 70, 50, 40, wherever you're at. This is where the IAC is going to be whenever you start. As soon as the engine sees crank to run RPM, then it will revert back to these IAC position settings for startup, and the hold time will hold for 4 seconds and then ramp down over a 4-second period. I/O on this is not really used unless you have the PWM set up, in which case you can set the output type, but you actually can't because the Terminator X setup uses a pulse width negative signal for all of your outputs. All right, last one, Spark ICF. Spark is extremely important, as most of you probably already know. The simple method is, in my opinion, wholly inadequate. It will make the engine start and run, but that's about as far as I'm willing to give it. When you are driving around and you're idling at 900 RPM and 12 degrees of ignition timing with your, slightly, larger than stock camshaft, and you go to pull away from a stoplight, you're going to, especially this is even worse than stick cars, you're going to go rev up the engine a little bit to 1200 or so, and you're going to see a big drop in manifold pressure, and you're going to have exactly the same amount of timing at the same time. It's going to ramp up here, and you're going to be flirting with this region where you're going 12, 18, 24, 18, 12, 24, 18, 12. It's too sharp right here. It's way too sharp right here, and what ends up happening is the thing will just buck like crazy because you're seeing these massive increases in cylinder pressure because you're flirting all over these ranges of spark timing, and it goes high and then it bucks and then it shuts off and it goes low, and it's a horrible situation. It's a horrible situation. Don't do it. I highly recommend, at least if you're going to use the simple table, that these numbers be much closer together. Like at least do this. It's not enough. It's not enough. You need to go in here to your 2D table and build a 2D spark table that's decent. I don't know why we have so much timing right here. I don't know how we have so little timing right here. I don't like this timing table at all. It makes me want to barf, throw it away, call me for a tune, whatever you want to do. Just don't use this. Don't do that. I can't stand that. Graphs explanatory. Look at this thing. Is that not obviously not how an engine would ever actually run? This thing just absolutely kills me. Okay, enough on that. Cranking. I usually will drop this down just a little bit, but 15 degrees is really okay. It's just the amount of spark timing during cranking that you're actually going to receive. Crank to run RPM just means that below crank to run, we're going to use the startup fuel and the startup cranking timing. Above the 400 RPM, we're going to start our IAC ramp down. And usually, whenever an engine's well tuned, it's going to flare when you fire it up to 1300 or so RPM, and slowly settle down. Rev limiters. This is always fun. We got the main over rev limiter. You can set this to many different choices. Spark high only is going to catch about 95% of you. And then obviously set the RPM that you want to limit at. Rev limiter number 1, this fools a lot of folks, but rev limiter number 1 is actually just the 2-step. Also, spark high only is going to catch most of you, but you set this to something like 3,000 RPM, 4,000, 6,000 if you're crazy. And then the way you use this, I'm going to jump around just a little bit, but the way that you use this is you would then come up and assign your rev limiter to one of your inputs. And so whenever this input right here sees ground, then you can activate the rev limiter. Launch retard, this is where you set up if you want to pull timing based on something right after you launch, or as you launch. If you push a button to launch the car, you would use activate with input. If you release a button, like a trans brake button, it would be activate at input release. This can be changed between RPM and time. Most of the time you're going to end up using the time function. But it's just simply a how many degrees we're going to pull of timing based on whatever parameter you want to use. If you set this up, you need to go in and set which, see this launch retard right here. If the trans brake was on A13, we would also put launch retard on A13. So when you release the input for A13 or number 3, it would activate the launch retard. This is where you're going to set up your knock timing pulling. I'm not going to do a lot of detail on this because most of us don't even use the knock, but it's just simply based off of your map and RPM, what amount of timing you want to pull given the fact that you would ever see any kind of spark knock. Timing versus coolant temp, this is good to set up. It'll help you fire up a little bit better whenever it's cold, and you can pull some timing if it gets too hot. Same thing for air. You can fire up and have a little bit of a timing bump whenever it's cold outside, and then also if you have really high IATs from a boost application or something, you can pull timing. And lastly, inputs. This is where you can change what type of input you want to use for your launch retard and your rev limiter. Like say for instance your rev limiter switch on your clutch, say it's a factory switch, it sees 12 volts in order to turn the clutch switch on, and you need it to use ground, right? No, not always. You can just literally come in here and set this thing to 12 volts and put this on your input, and life's grand. You don't have to put a relay in or wire anything goofy or do anything like that. You can just switch it right there. All right, we kind of touched on how the pin map works. You can set your inputs right here and your outputs right here. Just got to assign this stuff so that the Holly knows how to talk to everything, but that's basically it. I've already done a video, I think, on some of this other stuff. This, whenever if I was connected to an ECU, would give me the option to toggle the data logger. If I was connected to an ECU, I could sync with the ECU right here and do some functions like TPS auto set. This is the gauge setup if we were connected to the car, and the strip chart if we were connected to the car. I'm going to end it off there. I think you guys can probably figure out how to save your tunes and everything. But as always, it's been a pleasure. And if you have any questions or comments, please leave me a comment below, and I'll be happy to answer it. Thanks a bunch, and have a great day, guys.